All right, it appears like we're live. We have a couple more minutes before we start the broadcast and people trickle in, but why don't I go ahead and start by introducing you?
Okay.
Hi, everyone. Welcome to the show. You're listening to Sasha Talks Tech, a podcast about technology, innovation, and leadership. And today we have a very exciting guest. It is my pleasure and privilege to welcome into the studio Daniel Popescu. Daniel is a machine learning engineer in Arkris, Romania. So, hi, Daniel, welcome. Thank you for joining.
Hello. Thank you for having me.
Absolutely, it is my pleasure. So, today we're going to be talking about natural language processing and chatbots and what the new generation of intelligent chatbots looks like. So, Daniel, first I want to get started on your background. You started as a web developer and as a software engineer until you became a machine learning engineer and eventually got interested in NLP. So I was curious, what sparked your interest in natural language processing?
Actually, at the beginning, when I started with ML, I was pretty hooked to computer vision. But then I got this job at Arkris that involved constructing a chatbot, and it kind of made me look more into detail in NLP. And after that, I kind of got much more interested in NLP because there are a couple of reasons for me. Like a very big one is you can kind of play with it with models a bit easier, because they're not as big as computer vision ones. You don't need as much power for them. Um, and also because in the last few years there's been such a big revolution in the field in NLP. I mean, there's also been in computer vision, but that's been going on for a bit more, like a decade now, But in NLP, in the past 3-4 years, it's actually been way more of an evolution, and things change pretty rapidly. And yeah, and I think also because in NLP you can kind of play with things having meaning in a way, like it's so much more you can do, kind of like I don't know. For me, it made a lot more sense that you could combine a lot of other different things, and you could actually do a lot of things without having to train a lot at first. Like you can use a lot of pre-trained models and a lot of libraries to just play around and do stuff. Whereas in computer vision or things like that, you mostly get directly to the training part, to data sets and things like that. Yeah.
Yeah, I have to agree with you on that one. I personally find NLP quite fascinating, but it's that linguist in me because there's so much to it. There is sentiment analysis, there is frequent terms analysis, topic modeling, named entity recognition, and so on and so forth. I could probably talk about NLP all day. But I was just curious, what does a day in life of an NLP engineer look like in your company?
Uh, for me, I guess a day in life for me would be a bit different than a general one because we're a startup, so the project is still in its early steps in a way, So we're kind of trying different things a lot. Um, Mostly, uh, at least at the beginning, we focused on just gathering a lot of data, kind of, to be able to train a bit what we're doing. Because maybe I should talk about what the chatbot does first, so I can explain a bit more. Like we're doing a chatbot that tries to interview people, like a small pre-interview for any kind of job, really, because they're mostly the same as pre-interview goes. And yeah, for that we kind of had to gather a bit of data to be able to link all the concepts together. Um, at first, we worked a lot at the architecture of the bot. Um, Chatbots are still kind of even with all the advancements made recently, they're still kind of rudimentary in architecture, let's say, because um, you still need a lot of programming on your own to do, like
A lot of data.
yeah, a lot of data and a lot of ifs and algorithms and things like for it to go well, because you could train something that just tries to talk on its own, but we're still not there in a lot of ways in NLP. So mostly you have to try to architect the bot as the story of the bot, kind of as best as possible, so that you guide the user, through the process through his story as well as possible in a way. And that's mostly like uh, I would say 80% is working on the different actions and making sure each step is like works as well as possible. We understand what we expect to understand there, and not go off the rails and start responding very weirdly to the user. Like most of the time, that's the case. There have been some other more interesting things, like trying to build a knowledge base with graphs and things like that, but that's just mostly playing around actually with different concepts.
Yeah, I know chatbots have been around for quite a while, but even despite of all the exciting work and research that has been done in the topic, I feel like chatbots are still in their infancy because human language is so complex. You have to recognize intent and sarcasm sometimes, and sometimes there is ambiguity. So the chatbot at Arkris you are currently working on, you mentioned it's an interview chatbot. Is it to interview potential employees?
Yeah, yeah, yeah.
Okay.
The way it goes, it's like at first the current story we have for it, it's that at first we kind of ask you a few questions like um, so we know the job you're interviewing with. We start based on that, and we ask things like, okay, what kind of education you have that's related to this. Then, kind of based on the job description, we try to extract different entities from that and ask questions regarding those. Like for example, in a Python job, you'll get asked how much do you know about I don't know, Flask or things like that. How much experience you have working with X, Y, Z, and things like that. And depending on the responses, we try to kind of make a score and try to get a feel of how experienced and how best a match the candidate would be. Kind of.
Interesting. Have you had any situations when candidate either intentionally or unintentionally um, misled the chatbot?
Um, well, not really, because mostly what we've been testing was with people close to us in a way. So not people that would intentionally would try to break it. Let's call it like that. That's the thing, because with chatbots you can still break them quite easily. It's pretty normal. Like we have to understand that almost at any point we're still looking for a few intents at any stage in the process in the story. So if you start talking about very different things, you can be a bit prepared for them, but still, you know, it's very easy to break a chatbot right now, because in our minds, like the ones that test the chatbots, especially ones people that don't have like technical experience. Yeah, that's right. Candidate can influence the direction of the chat. Yeah, like a lot of people that don't have technical experience will easily find ways to say something you haven't thought about in a way, and they still think. I mean, it's normal, and I hope at some point we'll get there. But most people think of chatbots as actually very intelligent things, which unfortunately aren't yet. Like
It's
we
not
try to
always the
make
case.
them. We try. I mean, I don't want to sound negative, but we still have a lot of ways to go till we get to something that's really intelligent and really is able to kind of understand the meaning behind what you're talking about. Because right now we're just kind of classifying what you're saying, trying to extract entities from the text. Um, but linking meaning of sentences and things like that, that's way more abstract in a way. Like even the best chatbots around, the conversational ones, like from Google or Siri or things like that, they aren't able yet to link more than 2-3 phrases through 3 exchanges between a candidate and a chatbot, and they kind of lose the story they were on in a way. So when we're talking about the chatbot like I'm working on, which I kind of call task specific chatbots in a way, like chatbots that are focused on a single story, a single task. Like in our case, we go through an interview process. In those cases, you try to just keep the user on the story, and when he tries to go off the rails in a way, you kind of have to be prepared for it, and just as friendly as possible say, okay, let's get back to to the task at hand, because I don't really know what you're talking about. I mean, a lot of people are already like very tired of hearing the phrase I don't understand, that catchphrase that you get from all chatbots. I don't want to understand what you mean. Please say it again in a different way or something like that. And uh, I guess the key here is just to try as much as possible to not get there. Um, but at the same time, to have it in mind that at some point you will get there. Like no matter how much you train and how much you prepare for different things people might say to your bot, uh, people will surprise you, especially when you give the bot to test to people that are not technical or things like that. They tend to just go with it and say whatever comes in their mind. and that's why I guess it's better to just be prepared for it to kind of break in a way, but don't show that it breaks. Just make the chatbot be kind of polite and get back to the last conversation note that was actually useful to it in a way.
So yeah, it's actually not difficult to break a chatbot. Have you heard about the Tay bot on Twitter?
No.
It was one of the bots that I don't remember who launched, but of course, internet never disappoints. And the users, probably even unknowingly at first, started interacting with it and essentially training it, providing the data set. And as a result, the bot became almost it started leaving inappropriate comments in a way that the Twitter had to get rid of the bot. I feel like that's what's in common with young impressionable humans, aka children, and the chatbots. They're just like sponge. They absorb all the data, all the training data, all the lexicon that comes their way, and there's just so many things that can go wrong. So much can go astray. But do you think in the future we would still be susceptible to that bot kind of a bot misusage, or do you think in the future the bots will be more immune to it?
I think we're already. I mean, I know we're already close to cracking at least a bit of this problem. Like, there's been a lot of research in that direction. Um, of course, till we get a complete solution, there are like smaller solutions that you can just link together, like try to be able to remove negative words and negative sentences and things like that. Be careful about profanities or sarcasm and other things like that. You can try to train a bit a language model to recognize these things. But I think we'll actually be way better in this regard and get rid of this problem when we'll be able to give the bot a lot more information about the concept that he's talking about at a certain point. Like let's say I don't know. Let's just say that at some point someone talks with the chatbot and tells him, I want to know how to get to space, and the chatbot, if he'll have access to what space really means, in a way, and not just have it trained in the language model as a simple word that is connected to other words, will maybe he'll be able to respond more exact and more profoundly in a way. But right now, even like it's still amazing what we've done with language models. The level of understanding we were able to kind of embed in the language models, because training with a lot of text made possible to have different relations between words and also phrases. But we're still quite far away from actually having a detailed explanation of what words are. Like I think when we'll start combining chatbots with knowledge bases, with ontologies and things like that, we'll have a lot more flexibility in that area, and the chatbot will actually start kind of being able to understand the meaning behind a sentence, and not just not just similarities.
Mhm. Okay, I see. So to answer Manpreet's question about what's going to be the next breakthrough, would you say the next breakthrough that we anticipate would be the more insightful chatbot that can filter out valuable statements versus statements how to get into space?
Yeah. I mean, in the last few years, especially in the last 2 years, there's been a lot of research going into trying to link knowledge bases with chatbots. Different, very different ways, but very different approaches. But people feel like researchers feel there's something out there. They feel that that's the next step in a way, and there's been a lot of focus on that. One of the more bigger and more popular ones has been something called the Open Dial KG from Facebook, I think, which was able to kind of link parts of knowledge bases with a chatbot during conversations, and it already was able to greatly increase its kind of its effectiveness. I think they tested it on Squad on the Squad data set. The where basically chatbots have to answer a question based on like they're given a small paragraph, they get a question that the answer is usually in that paragraph, and they kind of need to extract it. And that's been the benchmark for a lot of chatbots in the past few years, and they had some pretty interesting results with linking these knowledge bases. Because as I said, like for us, we kind of get the idea that it will give him more understanding of what's behind that. We still have to find out exactly how to do that linking to go well. And as far as how soon can we have that, I don't know. I hope as soon as possible. Uh,
Hopefully in our lifetime.
yeah, hopefully in our lifetime. I'm pretty sure actually it will be in our lifetime, a version of it, because I don't know if we'll have a real AI in our lifetime, but close to it, much closer than we are now. Right now we already made some pretty amazing stuff, and for let's say for untrained eyes, some applications already seem like they're very smart and very real. Like we heard about people getting in love with Siri or things like that. So it fooled some people already, and that was just the beginning. Imagine if he'll actually be able to hold a conversation that's not just based on simple sentences, and he'll be able to keep up with everything you say in a way.
I wonder the thing with the Siri. I wonder if Siri actually passed the Turing test for being a conscious machine, or is it making a human believe that he or she or the Siri entity passed the Turing test to make the human more relatable and make them more inseparable as a tandem?
Yeah, that's an interesting point of view. I mean, I don't know exactly if they tried to make it pass the Turing test, but we have to understand that actually the Turing test um, is not just a set of questions. It's more like after the first bots pass the first version of the Turing test, like Elisa was one of the first chatbots in history, like one of the first better chatbots in history, and it passed the first version of the Turing Test, which was at that time quite, let's say, easy compared to the current ones. Um, and you have to imagine that Elisa was made like in, I think, 1980 or something like that. So 30, 40 years ago, it was just based on pattern matching. We didn't have any concept of, I mean, there were some ideas of uh, neural networks, but very small ideas. It was just using pattern matching, and it was still able to fool some people in like into thinking they were talking with a real person. I'm pretty sure Siri already like surpassed that a lot and was able to pass some version of the test. But from what I know, it's been updated to kind of yeah. I don't know more about it actually.
That's okay.
Uh,
It's more of a philosophical question. The thing with Siri, sometimes it cracks jokes with you, which are probably
yeah,
pre-programmed, but it allows for the conversation with the Siri to follow more flawlessly. Because the thing is that nobody wants to speak with the robot. They want a
yeah,
human or a human-like interaction, someone who would get their needs, especially if they're complaining to the customer support chatbot, or they want the answer to their supposedly unique problem or question.
yeah,
I feel like we as humans, we are longing for the human interaction, whether it's coming from a human or chatbot. So, what would you say is the main difference between the older generation chatbots and the contemporary chatbots? You already mentioned the pattern matching, where I'm presuming they would hard code all the possible answers and the pattern
exactly.
would match identically.
Yeah, yeah, yeah. Like let's kind of go back to Elisa a bit to explain that. Like when the guy that did Elisa, which has a very complicated name that I don't remember, um, so Elisa was supposed to simulate psychotherapist, and basically he did a lot of patterns, looking for things like, okay, if he says I am depressed, or other similar words with depressed, Elisa would automatically respond with a predefined response, as you said, like hard coded predefined response. Why are you depressed? What do you think makes you feel like that? And then he'll say something else, and again he'll look for a lot of patterns in what he'll say. But we have to understand that because of the nature of sentences and how they can have a lot of different so there's hundreds of different ways to say one thing, like I am depressed could be said in so many different ways, so many different configurations. We can't really expect to cover all of them in pattern matching. So he was kind of using. He was trying to look more for words or key phrases, but because of that, he wasn't able to actually look at the whole sentence, So, for example, someone might have said actually the entire sentence might have been something like, "I was depressed, but now I'm feeling a lot better," And Elisa might respond with, "Why are you depressed?" Because it kind of matched the first one and didn't consider the second part of the sentence, and that was kind of the limitation of the time, because of course they just tried to to simulate interaction and just tried to be prepared as much as possible for all kinds of combinations that they came up with. But the difference now is that we actually try to look at the whole sentence, and we try to kind of we don't have these predefined patterns that we're looking for. It's a bit more complex in the way that of course again we kind of have a data set that we train the bot to recognize on. Like we still have a few examples for that for a specific case that we're looking for, but because of the way language models have advanced and are trained, we can kind of expect them to to derive what we're looking for, to derive the meaning we're looking for from a sentence. I don't know if I think I don't know if I explained it quite right, but kind of the big difference is that before we were just having very little data, even if like one guy worked months on constructing a data set. That data set would still be very small compared to the data set available to a knowledge model, to a language model. Sorry,
Okay.
today,
So if I'm understanding correctly, chatbots back then versus the chatbots now, we throughout all those years we have been able to evolve from the bag of words algorithm, where the chatbot picks up on keywords such as depression, anxiety, and so on and so forth, to be clued into the emotional state of a human chatbot is conversing with. And nowadays we have such complicated algorithms such as word embeddings and vectorization and all that dependency parsing, where the chatbot should be able to pick up on the emotional state of a human without being explicitly cued through the terminology as depression, anxiety, and so on and so forth. So do you think that leads us to more empathetic chatbots, or chatbots at least that appear to be empathetic in order to mimic their human counterparts?
I mean, you said it you explained it very nicely. And yeah, you said a very important thing there with appear to be, appear to be empathetic. And yes, I do think that now they, of course, appear to be more empathetic because they just understand better what we tell them in a way, like I guess it all goes back to the fact that now, as opposed to 10, 20 years ago, the error rate of understanding something is a lot smaller. Like right now we just based on the language models we have, we understand the meaning of something. We classify a text much better than we did a while ago. And based on that, of course, the programmer can code some predefined things that make the chatbot appear to be one way or another. But I guess it all goes back to the fact that now that error rate is a lot smaller, and because of that, the chatbot can appear to be much more intelligent in a way.
Okay. We do have a very interesting question from the audience. Thank you for that, Shekhar. So we're trying to find out if the chatbot needs to be built specifically for the task that you have in mind. For instance, like in your company for interviewing new employees, or for Siri providing directions to the closest grocery store, or whatever. Or can you actually build a universal chatbot to help you with any questions out there? Is it even realistic?
I mean, right now, I would say it's not really realistic to build something very generic. I mean, people try, and we can, like Siri or Google Assistant or things like that are what we would call generic chatbots, in the sense that they kind of are able to respond to anything you say and at least give you some feedback back. Like, if you ask about the weather, of course they are pre-programmed to look for the weather. But if you ask about something a bit more specific, they'll just look on the internet and give you a response based on Wikipedia or things like that, and that's like mostly what we have right now. Or for example, if we take into account what's being used with GPT 2, 3 in the last 1-2 years, where they kind of try to generate text based on what you give it. That might seem like a general chatbot in a way, like he'll be able to at least give you some text back, but this comes back to the same problem in a way that we still don't have the capacity of the chatbot to actually understand what the user is telling him. So in general, that's why for me, like, I'm putting chatbots in two big categories. These what I call task specific ones that kind of are trained and have a clear story to follow and are focused on a very specific thing, and the general ones that are kind of conversational and just respond with whatever the language model or the chatbot as a whole is able to generate on the spot. But that's the idea. He just generates a response on the spot based on what you tell him and what he's been trained with, from the text he's been trained with. Like you can try to train like a general chatbot, for example, based on GPT-3. If you would use it now, they use kind of every type of text around there, news, articles, even scientific articles. So he kind of is able to generate any kind of text if you give him a small sentence that starts him. So you could call that that he is able to generate general things, but the distinction is, of course, that he'll not really understand what you're talking about. He won't be able to point you further in one direction. A specific task bot will kind of look for certain things that you're saying and will try to do something with them. Like we'll try to extract some clear entities and do something with that entities and come back to you with something more than just a generated text. I don't know how well I responded to that, but that's kind of my view for it.
No, that makes sense. So, would you say, for example, with the sarcasm, is a chatbot capable of picking up on the sarcasm? Let's say if there is sarcastic review on Amazon from the customer, I know it probably won't be able to appreciate the human's sense of humor. But would it be possible for the chatbot to extract the meaning even if the review is sarcastic?
Yeah, sure. I think so if he's trained on it, you know, like it's pretty easily if the developer thinks about putting some of those sarcastic variations in the dataset that the chatbot is trained on, then sure, I think he'll be able to kind of pick to understand some of them. But that's the big if he's trained on it.
Okay. Because one of my guilty pleasures is sometimes reading the Amazon customer reviews. And oh my God, those people never disappoint. Some of the reviews are so hilarious, and the people's sense of humor is so poignant that I can't help but wonder if it takes the human to go through the reviews and actually mitigate the crisis or lack thereof, or if Amazon is actually able to do it all automatically on the level of the chatbot.
I don't think I don't think they're able yet to do it all automatically, and I don't think they want to take that risk. Like because if it gets it wrong, it might be really bad for them, for their image and things like that. So I think they still have some fallbacks, like they still look for kind of a confidence score or something like that to tell them, okay, for this comment, we classified it as, you know, positive or negative, or probably it's more complex than just positive or negative, but let's say for the sake of discussion that it's only positive and negative. And the chatbot, the model classifies it that way, but of course we kind of get some confidence score, you know, for it. And I imagine they kind of filter them out, and those with low confidence score are then verified by other people. I don't know if it's like that. I don't have any any connections with people from that area, but I imagine. I mean, that's how I would do it, at least as a rudimentary fix. You know, I imagine it's a bit more complex than that because you have a whole team of developers and not just a few for that. But for example, in our case, that's kind of how we do it. We try to focus on the confidence score of something that we identify, and if it's not good enough, we kind of ask back the user if we understood correctly, you know, which is kind of the process of disambiguating something. You know, you see if your model isn't sure about something, you kind of I think it's best to ask the user, hey, did I get this right, or did you mean to say something else?
Yeah, can always clarify. It's always best to remove the ambiguity. In order-
Yeah, and that's actually a great tool to also gather data for training, you know, because if the user responds and says, okay, no, I didn't mean that, or I did mean that, then automatically gather training data. You know, you can kind of put their response as so. Let's say that. Um, the user said, I don't know, he said something, and the chatbot classified it as intent X. Um, but he wasn't sure, so he asked the user, "Did you mean X or Y?" And the user might say, "Yes, I did say I did mean X." Then we can of course put it in a data set for the X intent, for the X case. Or if he says, "No, I didn't mean that, I meant something else," then we can kind of be sure to remove it from the data set, or use it as a something to look for as as a counterpoint for that, which is sometimes used, but that's we're getting into a bit more complex things already. So yeah.
Well, NLP is a complex and fascinating field. I've been reading recently about new developments such as BERT. I believe it stands for bidirectional encoding transformer or something like that. So it picks up on very sophisticated sentiment analysis. And I believe the model is so big that you can't even train it on your own machine. You have to get the pre-trained BERT models. And I also heard about the GPT-3, but my knowledge of it is a little bit hazy. So do you have a favorite new emerging algorithm? And can you walk us through a little bit through that?
Sure. So as far as favorite, not really, because they're very. It really depends on the task at hand. So, like you said, we have BERT, we have GPT, which before GPT-2 was the greatest thing. Now this year, actually, I think late last year, GPT-3 came out.
Now GPT-3 is all of the talk of the town.
Yeah, it's the new guy on the block, and makes all the fuss and things like that. It's interesting because they of course use the same fundamental thing in their architecture, which is transformers and the attention model. They do use it a bit differently, and the way they're trained is a bit differently. So GPT, be it 2 or 3, it doesn't really matter, uses something called auto regression, which means basically we take, it's trained based on text. It tries to predict the next word in the sentence, basically. Okay, and auto regression means that we take the first word, we predict the next one, and then we add that one to the sentence we have so far, and move forward. BERT is kind of different, and that's actually one of the things that made it such a big thing at the time. He looks at both sides of the sentence. Like if we have a sentence, let's take a simple sentence like, I don't know, BERT is the greatest. And let's say we're looking at the word the in that sentence. BERT will look at BERT is and greatest, from the sentence. GPT will only look at BERT is. He won't know anything about greatest up till that point, which kind of limits it a bit. But that's the thing. GPT is mostly used for things like generating text, and of course, based on it, people started using it on other tasks. But that's kind of the big distinction between them. Bert looks at the whole sentence and tries to get as much attention scores from all the words. Like he tries to use the other part of the sentence. GPT just looks at the beginning up till that point. That's why even if like another big distinction is that GPT is way bigger than BERT. Even the GPT-2 model was a few times bigger than BERT, and GPT-3 now is enormous, like way bigger than 2, in the scale of hundreds, you know. I don't know the exact number, but we could say it's about 1 to 100 bigger than BERT, than the large version of BERT, you know. So we're talking about very different scales here. When you said that you can't really train BERT on your on a normal computer, imagine that well, you can, but it will take quite a lot. GP2 is really impossible to train on a normal computer because it's so much bigger, you know. But this brings us kind of to another distinction between them, which is because it's so big, because GPT is so big, especially the latest version, the GPT-3 version, it developed quite a lot of understanding inside it. So you have to do far less fine tuning for it, you know. By its own, it's already able to solve with very good error scores a lot of problems, a lot of benchmarks, you know, as opposed to BERT needing fine tuning for every one of them,
Mm-hmm.
which, you know, it's kind of as I said, depends on what you need at that point. And of course, GPT-3, especially right now, it isn't, the architecture isn't open source, so you don't really have access to it. The guys from OpenAI made it available as a product, so you kind of have to pay to use it. I know it's available as a free trial in some capacity, but in the end, you kind of have to pay to use it on their platform in a way, as opposed to BERT, which is open sourced, which Google offers a lot of pre-trained versions for it, and also especially Albert came along, which is a modified version of BERT, which is much smaller. We're able to use it in even mobile phones and things like that. So that's great for smaller tasks, you know. And yeah, that's kind of, you know, comparisons between them.
I think that's something so powerful. It's probably a good thing that the access is restricted to certain people and entities, because imagine it's almost like a weapon, it's like a loaded gun. And I feel like if it ends up in the wrong hands, there would be some consequences. So I personally do like the concept of regulated floodgate.
Sure.
I think it's actually for our own safety at this time, because there's not so many laws protecting rules of users and just general internet users these days, because this whole industry is relatively young.
Yeah, I agree. I mean, in the past few years, a lot of organizations tried to start regulating things like this, you know, and there's been a lot of talk, but not that much action towards this, not yet. So when, for example, OpenAI came with GPT-2, it actually decided to not make available their biggest version of it. Like they had 3 versions, I think, or 4, and they made available just the first 2. the last one, which was the biggest one and was actually able to generate pretty amazingly human-like text, they decided not to make that available as open, especially exactly because of this, because they thought it would be used to generate fake news and fake tweets, fake reviews, and things like that. And uh, they were kind of in that position in which they thought, okay, we did something amazing, but maybe it's too amazing, and we kind of have to take responsibility for it. And uh, till we get more tools that detect these kind of things and are able to kind of regulate this, it's best to hold off on it, because indeed, there are a lot of of people out there that would use it in quite bad scenarios, and yeah.
Yeah, it sounds really scary because without the proper regulation in place, um, internet will become a breeding ground for things like fake news and conspiracy theories and so on and so forth. And I believe it's really important for us to have some sort of filter in order to prevent from those facts that are not truthful from propagating.
Yeah, yeah. I mean, in the last few years, I especially saw in almost all my feeds from newsletters regarding AI. Almost all of them, at least once a month, there was a news about regulating AI in some way, and uh, I mean, it's good that a lot of people take interest in this, and there's been a lot of research recently in it. And I guess it's also good that yet we still don't have the capacity, like a normal being that by itself, like a normal developer by himself, doesn't really have the capacity to train such big models yet.
Mhm.
Because you have to understand that even BERT was like, especially the large version, was trained about 2 weeks on 16 different what do you call them?
Like a supercomputer?
Yeah, like it used 16 GPUs in parallel for about 2 weeks. Imagine the cost; it's quite high, and so like a normal developer doesn't even have access to one good GPU sometimes. So
I don't
16.
think very many people have access to this kind of resources because this kind of number crunching takes insane computing power.
Yeah, and I mean, it's also like you might say that, okay, yeah, sure, let's calculate a bit. Okay, we get like $1,000 to $2,000 to use something like that. But you have to take into account that that's the period only for when you're sure of the model and it's complete and it's the final training of it. But as we know, we do a lot of testing and trial and error and things like that. So you actually end up with much bigger time and much bigger numbers than that. You won't just train it once and that's it. And so yeah, I guess kind of it's good that it does take so long to train something like this. That means that not everybody can do it. It's kind of good to to limit it a bit in a way. It's not good for us because we want to play with things like this, but we can't really because it costs so much that we kind of are limited there. But yeah,
Yeah, we would all love to have access to that kind of resources, but we don't have access to the nuclear deactivation button for a reason.
yeah,
And it's the same thing with those GPUs. Some vetting and some background screening is probably needed in that scenario.
yeah. I mean, you're right there. Yeah.
So let's talk a little bit about NLP and deep learning. Does NLP always mean deep learning, or is there more to it?
Well, yeah, I mean, they are pretty separate in a way. In the past few years, of course, they kind of got mixed because deep learning was used massively in NLP. But we have to understand that even if we look at the words like natural language processing, it's quite different from just using models to just generate some text or to just make a chatbot talk. The whole field of natural language processing involves much more than just one simple task. It has like about 20-30 different tasks in it, and most of them actually aren't even like for most of them we don't actually use that much models, because for example we have tagging of words or things like that, which we already have very good algorithms from 10-20 years ago that are used. We don't have to use deep learning models for those. And I mean, even if we would use them, the algorithms that have been constructed are sometimes better, so it's not really always equal to deep learning because sure, we do use, like, deep learning actually refers to just training large models, right? From the deep learning phrase came from the fact that suddenly we were able to train larger models than 10 years ago when the computer power was smaller, the data sets were smaller, and things like that. But that's the thing. NLP is way older. Like we had very good translation, done even before deep learning. We have to remember that even in around 1990 and 2000, we still had quite good translation for especially for English, because a lot of developers used other approaches to it, and they mostly used big data sets of words and pattern matching and things like that, and they were able to to simulate the very good translation, and those things are still around in some capacity, even if most of us don't actually uh, use them knowingly. Like nowadays, if you go and find a tutorial online about doing some kind of NLP task, most of them will use something like Spacey, which is a library for NLP. And what we kind of have to understand is that inside Spacey, there's a lot of those algorithms. I mean, it also has a language model, but it has a lot of other algorithms that analyze text, that do the tagging, the dependency parsing, and things like that, which isn't always based on machine learning.
So there's a lot going on under the hood of the intelligent machine learning model, be it either machine translation or a chatbot. There's definitely a lot of work behind and a lot of programming. I was wondering, for those who are interested in NLP or are trying to get into natural language processing, first of all, is there such thing as an ideal background for that? Or would you say there is no one-size-fits-all formula?
I would definitely say there's no one size fits all formula. I mean, especially in the last year, I got in touch with a lot of people that came into this field, and they're from all different backgrounds, including things like researchers from biology or people that came from background of art, so very different backgrounds, very different basics. Um, I would say that so there's not really, you don't have to have a certain background to go into this,
Mm-hmm.
but you do have to follow some steps to get to be able to understand the concepts you're working with, so like at first you would of course need to have a good understanding of just programming in general, at least a bit. You don't have to be able to now compete at algorithmics competitions or things like that, but you do have to have a basic grasp of things. After that, again, like I get also this question a lot, like, do you need math? Do you need good math skills? And the answer is kind of depends. Depends on what you'll work with. But if you want to get more advanced, I would say yes, you do, kind of, because a lot of research papers and things like that do present things sometimes quite mathematically, and to be able to understand them, you kind of have to have that knowledge, and again, after that, you kind of need to first know the basics of machine learning in general before going to use more advanced things from NLP specifically, So yeah, there's a bit to go till you get to the actual NLP part. Some people kind of go straight forward and start directly with NLP without knowing exactly what machine learning is, and they do manage to do some things, but I'm pretty sure for those people it kind of comes back to bite them because yeah, it's at some point they'll meet some problem that kind of involves the fundamentals of how machine learning works, and if you don't know those, you'll get stuck in. Also, you won't be able to know where to go from here. Like uh, you'll 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 try to train, let's say, a model in different ways, but if you don't know the basics, you might just end up wasting such a long time, And I actually had this problem at some point, like I started with deep learning. I got excited that okay, I know a bit of stuff. Let's play around, and I quickly got a bit disappointed. Like I didn't know why the model wasn't working. Why can't I just make this train? But we have to understand that there's a lot of small small points that come into training something. There's a lot of things you have to adjust, and if you don't really know how they work together and how they work together, you might end up trying to adjust them for a very long time without having good results.
Yeah, I feel like, yeah, there is a lot going on, not just in NLP, but in the machine learning realm
Yeah,
in general. There's just so much going on under the hood that it would take a while to figure out the optimal weights for the model or the hyperparameter tuning. And don't even get
exactly.
me started on that. So, when you're just starting out, would you say it makes sense to pick up a very simple project and just start simple before you build up on it, before you do anything sophisticated?
I would say yes, because if you start with something more complex, you'll end up going back and learning about different things, and you'll end up kind of um, forgetting what you were doing at the beginning,
I'm guilty of this myself.
Yeah, I think we all are. Like as developers, that's I think that's kind of our natural way, and we kind of have to fight against it. I mean, it is hard because I think in this field of machine learning in general, compared to other fields of programming, you do have to have quite a bit more knowledge of the whole thing. You do have to have the basics down much better, because in my background as web developer, there you could start working with complex websites just by using the framework and not really having to know what's behind it so much, and because things are much more rigid there, so you could do that. And I know a lot of people actually that did that, and it worked fine for them. Then, as we said before, in machine learning, that's not really the case. You'll end up getting stuck and having to go back and learn what's this about. You'll have to research a lot and things like that. Yeah.
Yeah, but I feel like with machine learning, we have all this sophisticated state-of-the-art technology right at our fingertips. So I don't feel bad for wanting to reach for the stars, but I always have to remind myself that MVP, the minimally viable product, stands before all. And I always have to remind myself to, before I attempt BERT or anything ambitious like that, I have to tell myself, why don't I just try with topic modeling with Jansim and Spacey? Why don't I just do basic sentiment analysis using NLTK Vader? Or how about that basic looking word cloud? You have to start somewhere and you can always build up upon, but if you build a project outwards, I feel like it makes it much harder to troubleshoot.
Exactly. And I know this from like, as I said, I'm working at a kind of a smaller company, but even at the bigger ones, they still kind of do the same thing. They build a MVP and then go back if they have time and do more advanced things at every step. But they kind of do the same thing. They don't go and train sophisticated models for each step. Of course, you use at first smaller things, like you said, and then go back, and if you have time and if you need it, because sometimes you don't need it, then go back and do more advanced things. Yeah. And I actually very recently had this thing, like I was trying to extract some things, some certain things from sentences, and already started in my mind, okay, I should build a model with all these complicated stuff and things like that, and then just remember that, hey, Spacey kind of already has if you use dependency parsing and a bit of other things from it, you already get that. So yeah.
Spacey already has some pre-trained models encapsulated in it, and I think that's partially what makes it so beginner-friendly. In just a couple of lines of code, you can already achieve so much, and especially with the dependency parsing. We did not used to be able to do this just a couple years ago, and for me, it's just a giant leap. So let's say if our audience wanted to learn how to do what you do, should they start with the chatbots, or is it a little bit advanced for the beginner?
I mean, Uh, I wouldn't say it's advanced because in chatbots, especially, you kind of just use things that are already made in a way. Like in most cases, you just use libraries and don't have to code that much, you know. For a beginner chatbot, like if you go into more advanced things and you want it to interact in some cases a lot more in some more complex cases, of course you'll need to at some point train your own things. But in most cases and in most basic cases, you won't really do that much advanced things. So yeah, I guess chatbots would be a good intro to it because they kind of use most of the NLP tasks. Most of the you have to kind of solve at least a little most of NLP tasks inside the chatbot, you know, and you kind of through that you get experience with the whole area. Uh, yeah.
Okay. Yeah, and I just wanted to give a shout out to your Udemy course on chatbots. For those who don't know, Daniel has his own Udemy course that he created from scratch about the techniques for creating AI chatbots. And I did check it out a couple days ago, and I was really impressed by the quality and the simplicity of the information shown there. And by the way, I noticed the course is on sale right now. So if you're hesitating about getting it, just, check it out. But let's talk about the course's curriculum in a little bit. Uh, let's say, where does it begin? What the prerequisites are needed to get the most out of your course? And what would our audience members learn from it?
Okay, well, I mean, when I started just thinking about doing the course, you know, I kind of did it because when I started my work with chatbots, there weren't many good courses about chatbots around. Like there was one that was using sequence models and things like that, but that's really outdated now. You know, we kind of moved from sequence models to much more advanced stuff. Um, and I found that in my case, I used I did other chatbots besides this main one that I work on, and in those smaller ones, I mostly use just libraries, and it was quite high level in a way that you didn't have to get into the specifics of it that much. So I thought it's quite a good intro into NLP as a whole to build a small chatbot and at the same time kind of present some of the the overview of NLP, and that's kind of how I approached it. And also, uh, I was thinking that okay, as I said, if you get into NLP, you already have a bit of experience in Python in machine learning as a whole, maybe a bit. Um, you certainly at least have some experience in programming. So I kind of focused on mostly just presenting concepts and didn't really present that much of the code. I don't explain each function, each if and things like that. You know, I just say, okay, you have this function that does that. If you want to see more, you can, of course, the code is available at every step, and you can kind of look on your own and see. My intention was mostly to give you a theoretical overview of everything. So we kind of at first go over the theory of what NLP is, what are the NLP tasks, the recent models and things like that, examples of chatbots, how are chatbots used, differences between them. And then we just build a small chatbot that kind of tries to mimic a restaurant order. You order things from a restaurant. We have a small database with food, and we just try to kind of go through a small story that the user could get presented some foods, and you kind of are able to select different foods and end up with an order. The chatbot itself is not very complex because that's not quite the focus of the course. The focus is actually to learn through it the small difficult parts you get, like the fact that you have to be very careful when you construct the architecture of the bot. At every point you need to kind of be very careful of the intents you define. It really depends on that. So we kind of focus on that, on how to define the intents best, how to make sure you're able to extract entities. At the end of it, I kind of did a whole chapter just based on data because I thought that was quite important. The fact that most of us don't have much data available, and in some cases, for many bots, they're quite specific, and you don't really have data available online to get. But the good thing is that with the latest models, you kind of are able to do a lot with just a few examples. If you train models on just a few examples. So I focused on that a bit. I focused on how to generate more data with some techniques, how to do disambiguation and things like that. At the end, we kind of do a bit of extra work on the bot that kind of makes him careful of some of the more things that users might say to chatbots, like things like "Do you love me?" Does Santa Claus exist? There are a lot of things that people just say randomly, and I kind of took a list of around 30 or 40 of those things, and we make the chatbot to just answer with a predefined thing for most of them, and yeah, that's kind of it. So it's mostly an overview of things. We use libraries. We don't code that much. I think total the project has around 2,000 lines of code, so it's very small for a complete boat. But that's because mostly we use libraries and we just focus on the concepts mostly.
Interesting. So, would your restaurant bot accommodate people's food allergies and restrictions? And I want my pasta gluten free, and I'm vegetarian, and actually swap the shrimp for chicken.
Yeah.
Oh,
Yeah. You didn't finish, I saw.
that's a very sophisticated chatbot because
If you
nowadays.
get to about half of the course, you already get there and see that we do tackle a bit of those problems. Yeah, that's the nice thing, that you can actually do all those things with just very little code. Very little. Just by being careful what to look for, you kind of are able to do that. Of course, that's the thing. We as programmers kind of have to program those things. Like it won't understand on its own that it should look for food allergies, vegetarians, and things like that. We kind of have to program that. But that's kind of the idea. We kind of give examples to what to be careful of, what to look for in chatbots and things. Yeah. in a general way.
I'm really excited this course. Also, partially, there is one thing I've been wanting to build. There is a music festival in the United States that's called Burning Man, and it has a variety of tourist attractions there. I've never been myself, but the one I heard about was the bad advice booth. You literally pick up the phone and ask the person on the other end a question, and they intentionally give you bad advice. So I was thinking, how fun would it be to web scrape the Reddit data? And I'm 100% sure there is some sort of a bad advice subreddit there, and incorporate it into a bad advice booth, but as a bot.
Yeah, yeah, yeah. I mean, you could do that, and I mean, I think most of the work there would actually been in gathering the bad advice, the data for it.
Mhm.
The bot would be quite easy to do for something like that.
I feel like in terms of bad advice, Reddit never disappoints. But the
Yeah.
thing is, the thing is, web scraping of a website is that dynamic is a completely different technical problem. So we are running almost low on time. But before we go, um, can you recommend a good book for our readers? For our listeners to read, or maybe there is a Medium blog that you follow, or there is a podcast that would be useful to our attendees in their careers.
Um, as far as book goes, I haven't really gone into those in machine learning. I did read a lot of books when I was preparing for programming in general, but in machine learning, I found it's kind of more useful to go with courses, and when you get a bit more advanced, to just read the actual research. So
Mm, the actual
uh,
research papers.
yeah, like for example, last year I kind of had a challenge for myself in which I said, okay, I'll read for 2 months a paper a day, and which is quite the challenge because if you read the research paper, you'll know that you at least have to invest like 2 3 hours, at least 1 2 hours in a research paper to understand it. But you do get quite a lot of understanding of knowledge from it. Like you form some connections in your head that you can't really get from just courses that do overviews of things, but that's mostly when you want to get more advanced in a specific area. Like for me it was the NLP combined with knowledge bases. In my case, I was pretty interested in that. So I spent a lot of time reading research papers about those. Um, but I do think that for me, what worked best was kind of doing courses. Especially, I do recommend the ones from Coursera. Those, in my opinions, are kind of the best around. They
Coursera is wonderful. Andrew Ng is a
Yeah,
Bible.
no one beats Andrew, and he's our god for every one of us. I know a lot of us started with those, and I mean they do have quite a lot of good courses that are much better structured than others. Not to make bad publicity for my course or things like that, but uh, you know, the Coursera guys mostly use university level teachers and things like that to construct the courses, and they do have a bit more funding behind it, which makes it quite a more complete course in a way. So especially for beginner things like beginning in deep learning, then beginning in NLP even, they this year they launched a specialization in NLP, which is quite good. Still, it's just a beginner thing. It's like you get an overview of things. You don't get to play with BERT or GPT or things like that, but you do get to understand the attention model, which is kind of the necessary step to get to play with the other things, you know. And I guess after that, the best thing, in my opinion, is to try to read some of the research papers especially regarding the big uh, points in the last few years. You know, like for example, in NLP, it would be word vectors, like the first versions, then Elmo, Gentium. Then we move on to the attention things. Actually, first sequence to sequence, then attention. You know, and then you come with you come to BERT, GPT, transforming cells, and things like that. After you kind of get those basics a bit more strongly in your head, you understand them a bit more. Then you can just try to go into a specific area that interests you, to a specific problem.
Interesting. Have you considered writing a book about chatbots?
No.
Because
That-
I notice there is a lot of good machine learning and NLP books floating around, and I do own a great bunch of them. But
I,
I'm yet to encounter a good one-stop shop specifically for the chatbot needs.
I didn't, because mostly I'm quite a perfectionist, I would say. So because of that, I don't really consider myself an expert in the field yet. You know, I'm still quite the beginner. So because of that, I wouldn't. I mean, I wouldn't try to gather that much knowledge before being able to be certain that the quality of the knowledge is good. Like I really hate it when I see online a lot of different articles that have big titles, but actually don't have much in them, and they kind of make you waste your time a bit. And so yeah, I don't know.
Okay.
If that,
I'm just planting a seed,
yeah.
and the address to the audience. Please let us know in the comments if you would be interested in such sort of a book, maybe hitting the market sometime in the future. I'm just curious. So, anyways, we're almost out of time. Oh my God, it's been such an insightful conversation. I feel like we covered so much in such short period of time. So, just to recap, we talked about NLP, machine learning in general, and the natural language processing. And its current state in the industry. We talked about careers in NLP, prerequisites, and the pathways into natural language processing, and also what distinguishes the contemporary chatbots and what's under the hood of the very sophisticated chatbot. All right. Thank you guys so much for coming to hang out with us today. It's been wonderful. And that's it on my end. My name is Sasha Prohorova, and thank you very much. And a shout out to our wonderful guest, Daniel Popescu. And please do check out his Udemy course. I bet you won't be disappointed. That's it on my end. Thank you for listening.
Thank you too.